Okay, we'll look at some of the homework problems that are in section 8.3 that deals with simple interest and compound interest. We'll start with problem number 1, where we're trying to complete the following compounded interest chart. In this case here, we have a principal of $1,000 here at a 9% annual interest rate for 3 years, and it's compounded monthly. We want to find the interest rate per period, the number of periods, and the amount of the interest that's paid. Well, in this case, let's start off with the interest rate per period. The annual interest rate is 9% and is compounded monthly. That means that there are 12 compoundings in a single year, since there are 12 months in a year. So we'll take that 9% and divide that by the 12 months. So that means that the interest rate is 0.75. Now the number of periods, well, there are 12 compoundings in a year because it's compounded monthly, and we're dealing with 3 years. So multiply 3 times the 12 is 36. So the number of periods that we're looking at is 36 periods. Now let's find out the amount of interest paid. We need to do that by using this formula. A is equal to the principal times 1 plus R, and R is going to be the interest rate per period, and that quantity is raised to the power of n. N is going to be the number of periods that we're dealing with. So all we need to do here is just replace some numbers with those letters with some values here. The principal is $1,000 here, so that's 1,000 times 1 plus. The interest rate is 0.75%. We need to change 0.75% to a decimal by moving the decimal point 2 places to the left. So it'll be 0.0075. And that's raised to the n, which is the number of periods, and that's 36. Okay, I want to show you how to enter this on the calculator. Let's say we have 1,000, and that's multiplied by, and then left parentheses, 1 plus 0.0075, and we close the parentheses. Now for the exponent, we use the caret key. We press that, and then our exponent is going to be 36. And then hit enter. Now we're going to round to 2 decimal places because we're dealing with money amounts, so it'll be 1308.65. So the amount that we have is $1,308.65. But here we want to find out the amount of interest paid. Well, if the amount is $1,308.65 and our principal was $1,000, subtract that $1,000 minus the amount of $1,308.65. That will tell you how much interest was paid. In this case, it's $308.65. Okay, so that's how you'll solve this particular problem. All right, number 2. Ernie Rolfe borrowed $4,550 at 10% annual simple interest. If exactly 1 year later he was able to repay the loan without penalty, how much interest would he owe? In this case here, this is simple interest, so we're dealing with this formula. I is equal to P times R times T. P is the principal, which is in this case $4,550. The interest rate, it is a simple interest rate of 10%, so it'll be, as a decimal, 0.10. We always change a percent to a decimal by moving the decimal point 2 places to the left. And our time, which is T, that's 1 year. So if you go ahead and multiply 4,550 times 0.10 times 1, you'll get $455. So in this case, Ernie will owe $455 in interest. All right, problem number 3. Carolyn went on a shopping spree with her bank amount card and made purchases totaling $175. If the interest rate is 1.6% per month on an unpaid balance, and she does not pay the debt for 1 year, how much interest will she owe at the end of the year? Okay, so here, let's find out what the amount is at the end of 1 year. And it's compounded monthly because it says per month. So we know in a year there are 12 compoundings in a year. So our n, that's going to be 12. So we're going to use this formula. A is equal to P times 1 plus R, and that quantity is to the nth power. So in this case here, our principal was 175, so it'll be 175 times parentheses 1 plus R. Now 1.6% as a decimal, we change the decimal to a percent by moving the decimal point 2 places to the left and dropping the percent sign. It'll be 0.016. And that's going to be raised to the n, which is 12. So in this case here, if we do 175, and then 1 plus 0.016 raised to the 12th, and I'll show you on the calculator how I did that. Now if you press enter, you'll see it's $211.72. So here the amount is $211.72. But we want to find out how much interest will she owe at the end of the year. Well, if the amount is $211.72, let's subtract 175, which is the amount of the purchases that she made. That's 175 from $211.72, which will end up being $36.72. So in this case here, she will owe $36.72 in interest. All right, problem number 4. A bank in Houston loaned $70,000 to a business at 10.5% annual simple interest for 15 months. How much interest will the bank earn? Okay, so this is a simple interest formula. That's I is equal to P times R times T. The P, which is your $70,000, your interest rate is 10.5%, but as a decimal is 0.105. Drop the percent sign, move the decimal point 2 places to the left. Now notice this time is in months. It has to be in years, so we need to convert 15 months into a number in years. Well, there are 12 months in a year, so 15 divided by 12 is 1.25. So the time is 1.25 years. Now, let's take the 70,000, multiply that by 0.105, and then times 1.25, and you'll have, now they say round to the nearest dollar. You'll get an answer of 9187.5, and I'll show you on the calculator. But to the nearest whole number, or to the nearest dollar, it will be 9,188. So in interest, that bank will earn $9,188 in interest. Problem number 5. A car company is offering car loans at simple interest rate of 14%. Find the interest charged to the customer who finances a car of $16,000 for 2 years. It is simple interest, so we have to use the simple interest formula. I is equal to P times R times T. In this case, the loan was $16,000, so that's our principal. 16,000 times the interest rate of 14%, as a decimal will be 0.14 times the time, which is 2. And then we just do our multiplication. 16,000 times 0.14 times 2, which will be $4,480. So the simple interest on a customer who finances a car at $16,000 for 2 years is $4,480. And finally, number 6. An amount of $3,000 was deposited into a bank at a rate of 8% compounded quarterly for 5 years. The rate then increased to 9% and was compounded quarterly for the next 5 years. If no money was withdrawn, what was the balance at the end of this time? So here we want to find out what the amount is after the first 5 years at 8%, and then take that and get the final amount for the additional 5 years, this time at 9%, and they're both compounded quarterly. So we know there are 4 compoundings in a year. Multiply that by 5 years, that's going to be 20. So that's our N. N is going to be the number of periods. So here we can use this formula. A is equal to P times 1 plus R raised to the N. And R, keep in mind, is the interest rate per period. So to find out what that is, let's start off with 8%. It's compounded quarterly, so divide 4 into 8%, you're going to get 2%. But 2% as a decimal will be 0.02. So we'll be using 0.2 in R in this problem. And the P is 3,000 times 1 plus R, which is 0.02, raised to the N, and that's 20. So when we do 3,000 times 1 plus 0.02, and that quantity is to the 20th power, we'll get, now to the nearest dollar, or to the nearest cent, will be 4457.84. So for the first 5 years, compounded quarterly at 8%, the amount which was deposited at $3,000 will accumulate to $4,457.84 after 5 years. And then our rate was then increased to 9%, compounded quarterly for another 5 years. So this amount was compounded quarterly for another 5 years at 9%. And we're still going to use this formula. But this time our new interest rate per period is going to be this, 9%, and we're going to divide that by 4% because it's still compounded quarterly. That'll give us 2.25%. Now 2.25% as a decimal will be 0.0225. Okay, so here, when we replace our variables with those given values, this P will be that $4,457.84 times 1 plus R is 0.0225 raised to the, of course, 20th power. So now $4,457.84 multiplied by 1 plus 0.0225, and that's raised to the 20th, we give you this number, $6,956.50. That's the balance in the account after this amount was compounded quarterly at 9% for another 5 years, and no money was withdrawn. So this will be your final answer, or your final amount, $6,956.50. Okay, this should be enough to assist you with some of the problems that are on the MyMathLab homework system.